Today we're going to build this interesting and unique steam engine. It's different from all the other steam engine models we have in that it has only a single takeoff from the turning from the flywheel. And at the end of the video I'll show you how that actually works. So, when you get the kit, it will have a variety of pieces made of acrylic. All those pieces will be covered with protective film, a blue protective film. One of them will have a protective film which is also itself relatively transparent, but if it's not crystal clear like that, it needs to be peeled. First step is to peel it all. We have a special video for how to peel acrylic without frustration, and I've obviously pre-peeled it, so we're ready to go. The first thing that you probably want to do is lay out all the parts and sort of sort them so you know what you're dealing with. There's a bunch of little nuts. There's a whole bunch of screws that are all the same length. There's one longer screw, and then there's all the acrylic pieces. We're going to start with the piece that has mechanicalgifts.com engraved on it. Maybe hard to see in the video, but easy enough to find in person. So take that piece with the word right side up, and we're going to take all the short screws and put one in every hole that is the right size. There's a couple of holes that are bigger and one giant hole, but all the holes that are the same size as the screws all get a screw. Just go through this one after the other. We're going to use up most of the screws. There are actually a couple of extra screws. Well, actually one extra screw comes with the kit. But okay, so now we've got screws everywhere, and then clear an area. And now take the second piece that looks similar, and we're just going to use that temporarily here to hold all the screws in place while we flip it over. Otherwise the screws obviously would all fall out. And then we want to slide this out. Okay, so now we're left with all the screws facing up like that. Now we take this piece that's made of thick, it's twice as thick as the top plate, and orient it so this partial hole matches that big hole. And it just sort of sits down on top there. Now we want to take these two little pieces. This one that's, I don't know how to describe that shape, but it looks like that. It goes here. No, it doesn't. It goes here, like that. Okay, and then this even more peculiarly shaped one, it goes the way it goes. How does it go? It goes like that. There you go. So basically these three passages with the curved holes, they all go along where the holes are in the cover plate. Okay, now we can lay in the moving parts. Start with, this is the piston. It sits in here with this part facing up. And then the connecting rod fastens on there with this sort of C thing going around that, whatever you call that. And then this guy goes in here, can toggle back and forth. And this thing goes with the C pointing down, goes on there with that toggle thing in the middle. Then we take this, also with the curved cutout there, fits on top. And finally, this piece, this is the flexible one, the very thin flexible one. And then the last piece, this medium 1.5 millimeter or 1/16 of an inch piece, it goes on top like that. Now whatever you do, don't pick this up, because if you do, all the screws will fall out. So the next step is to spin the nuts on. If you press down here, that will sort of hold the screw so it doesn't spin, and then just kind of spin these on. We're not even really trying to tighten these even finger tight. We're just trying to get them onto the end of the screw so that the screw won't fall out. Go through all the screws. back, I dropped one. Hopefully that will be recovered or not necessary. So we might have an extra. Otherwise, you'll see an awkward cut in the video at some point when the nut is returned. Okay, but fortunately we have enough nuts. We have an extra nut. Always try to give people an extra nut. Okay, so now all the nuts are on. Now we can pick it up. Everything is safe. The parts should all move. We want to now go and tighten all the screws and try to, go through systematically so you actually get them all tight, one end to the other. There is one, though, that you don't want to over-tighten. There's this screw here that needs to allow this part to move. So you can tighten it, and you want to get it sort of a little bit tight so it doesn't just rattle off, but don't tighten it any more than necessary. I mean, it's still moving completely loosely because there is actually extra space in there. So you can put a bit of pressure on there, but just don't tighten as much as the rest. The rest of the screws, you can tighten them pretty much as tight as you comfortably can using this tiny screwdriver. If you decide to use your own screwdriver that's bigger, then be a little bit careful not to put too much torque on or you could crack the acrylic. That's one reason why we give you this tiny screwdriver. It's because it's hard to over-tighten the screws. Okay, now that everything is tight, we now need to assemble the flywheel, which is missing. Okay, we're ready to continue after the magical appearance of a part that I had previously forgotten to lay out. So, we look at these 4 discs here. You see there's 2 larger ones, 2 smaller ones. 2 of them have 1 hole, 2 of them have 2 holes. We start with the larger single hole disc. If you feel a rough edge on one side, you can put that side up, make it turn a little bit smoother. It doesn't make that much difference. Put a screw through the longer screw through the hole, and then flip it over and set it down. Then we take the smaller disc with a single hole and set that on there. And now you'll see there's these little washers, clear washers. We want to take one of the thicker ones. It's about 1/8 of an inch or 3 millimeters thick. Stick that on. And then 2 of the very, very thin ones, one after the other, like that. And now take this thing. So I'm holding it right side up now, where the word mechanical GIF is visible here, right side up. And flip it over. And set it down so that those little washers we just put on go through the hole in this connecting rod. And then the smaller of the large discs there will fit into this big cutout. Forms a sort of a bearing. Okay, now we take the smaller of the 2-hole discs and put it on there, and then the larger 2-hole disc goes on there. And then another one of these 3 millimeter thicker washers goes on there. Now we're ready to put this on, but we have to prepare this first. So we take the remaining small screw. You'll probably have an extra one in the kit. Put that on through one of the 2 holes, doesn't matter which one, and just spin a nut on and tighten it. The purpose of this screw is just to have that little sort of peg sticking out there, a bit of extra screw sticking out. So we now want to adjust these so that the 2 holes there are in line with each other, roughly, because now we're going to put this on with the long screw going through the remaining hole and the peg fitting into both of the holes of both layers of those big discs down there to hold them locked in place. Now we put the last nut on here. You will have an extra nut, most likely. Okay, so now we want to tighten this, but just a little bit, not too much, and check for smooth operation. If you find that it binds, the 2 discs on the top here can rotate. See how they're not locked in place by the screw. And if you find that it sort of doesn't turn smoothly anywhere around, just sort of wiggle these and adjust them a bit until it's turning. It should spin very freely. And once you got it spinning nicely like that, then tighten this a little bit and check again that it's still spinning smoothly, and then just sort of get it tight once it's nicely lined up. And now you're finished. So The unique thing about this particular steam engine is the fact that it has only one point in which motion is taken off from the flywheel. All of our other steam engines, the circular motion of the flywheel is translated into harmonic motion, namely sine wave motion, at two different angles. So let's say the piston is coming off in this direction. We call that a sine wave. The motion as a function of time traces out a smooth sine wave. And then the valve in all the other models would be taken off at a 90-degree angle so that it traces out a sort of a cosine wave, a quarter turn out of phase with this. But that introduces mechanical complexity, having two different places where motion is extracted from the rotation of the flywheel. This design, which is modeled after a design that was actually used in some real steam engines, gets around that by essentially making up the movement, the cosine wave, an approximation to it by amplifying and clipping the movement of the piston. So you see what happens is, as it's turning, let's say we're turning in this direction, and at this point, now let's see, we'll turn this way. Now turn this way. So at this point, steam is coming in. Steam comes in these two holes and leaves here. So at this point, steam is coming in. Wait a minute. We have to go through a cycle. So it's turning this way. All right. So we're coming here. So at this point, steam is coming in here, flowing through there, through that channel, and pushing in this direction. As we arrive at this end of the motion, you see this mechanical leverage here amplifies the speed of movement here to very quickly flip the valve over in the other direction. So steam is now flowing here and onto this side of the piston. And as we continue the motion, the piston moves this way, steam is flowing out through that channel and out the exhaust hole in the middle, right up until we get to the other end, which point the valve rapidly flips over, and now steam can start feeding in there. So you see this works quite efficiently. The valve is moving very quickly, so the shift of steam pressure from one side to the other actually happens faster than it does in a version where the piston is moving also with a smooth harmonic motion. The trade-off is that this is a click-clack, it's not a smooth, harmonic motion everywhere. So it's louder and it, mechanical wear, slightly more complex in here. But on the whole, in many ways a simpler design, but less commonly used, especially in model engines, than the two harmonic motion version. If you have it nicely, smoothly operating like this, and if you're good with your timing, you can actually get this to go quite fast. This is, of course, the way a steam engine would really work. It's the piston that pushes and pulls rather than turning the flywheel. So I hope you enjoyed this model, and I hope you also get the other models that show you how the other way of doing this works. They're good to have together as a set. Thank you very much.